Hello everyone and welcome back. My name is Mr. Covalt, and in this video I'm going to be going over how to calculate the amount of product that's formed as well as the amount or concentration of ions that are left in solution when you mix two solutions together. So let's get into this. So in this video it's going to take me a little while because we got a lot to go over. This problem is asking, or it tells us that an aqueous solution of silver acetate, AgC2H3O2, 50 milliliters and 0.1300 molar, is mixed with 25 milliliters of a 0.300 molar ion or iron 3 chloride solution, FeCl3. And then they want us to calculate the mass of any precipitate formed and the concentration of each ion remaining in solution. So the first thing we need to do is to write out the balanced equation. We can't do anything until we do that. So let's do that. So the balanced equation, we know that our reactants are silver acetate mixed with iron 3 chloride. So let's write the formulas. We got to make sure we get the formulas right and then get the product. So we have silver acetate, AgC2H3O2, and this is aqueous, plus iron 3 chloride, that's FeCl3, and then again, that's aqueous. And then we got to figure out the products. So the first thing you want to recognize is what kind of reaction this is. What type of reaction does this fall under? And if you notice that you have one reactant is an ionic compound and the other reactant is also an ionic compound, anytime you have two ionic compounds, that's a dead giveaway that you've got a double displacement reaction. And so in double displacement reactions, the way you figure out the products is you take the outside ions together. So silver and chloride ions are going to come together to form a product. And the acetate and iron 3 ions are going to come together to form a possible product as well. So we just need to write the formulas. And remember, when you put the ions together, you have to balance the charge to make sure that the formula is neutral. So let's start with silver and chlorine. So they're both +1 for the silver ion and -1 for the chloride ion. So it's 1 to 1. So we just need AgCl plus our other possible product is going to be the iron 3 ion, which has a 3+ charge, and the acetate ion, which has a -1 charge. So this is our polyatomic ion. So we're going to need 3 polyatomic ions here. The 3 acetate has a -1 charge. Your iron here has a +3 charge. So you're going to need 3 acetate ions to balance the charge. So when we write the formula, it'll be FeC2H3O2 with a 3 on the outside. So now we have our formulas. Now we need to balance the equation. So I start with the metals first. So silver, I have 1 silver, 1 silver. I have 1 iron, 1 iron. So the metals are already balanced. Now I'm going to do the non-metals. So here I have a polyatomic ion, acetate. It stays together. So I'm going to treat this as one unit. I have 1 acetate here, but I have 3 acetates here. So I need a 3 over on this side. So I'm going to put the coefficient 3. So now I have 3 acetates on this side, but now I have 3 silvers on this side. So I'm going to need to put 3 silvers on this side. And so I have a 3 coefficient there. So now the silver is balanced. Again, the acetate is balanced. My iron is still balanced. So finally, let's look at chloride ions. So I have 3 chloride ions here, and I have 3 times 1 is 3. So I have 3 chloride ions. everything is balanced. Okay, last, we need to figure out whether we have a precipitate or not, because if we don't have a precipitate, that'll make the problem easier. All we need to do is calculate the moles of each ion from the original solutions and then divide by the new volume after you've added the volumes together. In this problem, again, we're going to assume that the volumes are additive, meaning that when you add 50 milliliters to 25 milliliters, the total is going to be 75 milliliters rather than something less than that. Excuse me. Okay, so let's figure this out. So from your solubility tables or your solubility rules, you'll know that acetates are all soluble, so there's no exceptions. So here we have a aqueous. And then chlorides are normally soluble, but there are a couple of exceptions, and silver is one of those exceptions, which means that silver chloride is not soluble. Okay, so this is going to be solid. So in order to figure out the amount of silver ions and chloride ions, we need to figure out how much of the silver ions and chloride ions are in this solid and subtract that from the amount that we started with. So that brings us to our next problem. So notice that they give us 50 milliliters of a 0.3 molar solution of the silver acetate. And then they give us 25 milliliters of a 0.3 molar solution of iron 3 chloride. This is a dead giveaway that we have a limiting reagent problem. Well, how do I know? Because anytime they give you the amounts of two reactants, and they don't tell you that one is in excess of the other or it reacts to completion or anything like that, then you don't know what the limiting reagent is. You don't know that they're going to react completely together, right? So we have to determine which one of these reactants is going to run out first. And the way that I'm going to show this in this video is by taking each of the amounts of the reactants and converting it to the product that we're interested in, which is our silver chloride, and seeing which reactant is going to give us the lesser amount. Because remember, the limiting reagent is the one that runs out first. And if it runs out first, then it's going to limit the amount of product that can be formed. And so the limiting reagent is identified as the one that gives us the lesser amount of the product that is formed. Okay, so let's go ahead and do that. So we're going to use stoichiometry to find the amount of silver chloride, formed from each of these reactants. So let's get into this. Okay, so let's start with the silver acetate. So we're going to start with 50 milliliters. So we have 50 milliliters of the silver acetate, AgC2H3O2. And what we're going to do is we're going to use the molarity to convert to moles, because remember, molarity is moles of solute over liters of the solution. But in order to use the molarity as a conversion factor, I'm going to have to convert milliliters to liters first. So let's do that. So I know that 1 milliliter of the silver acetate is equal to 10 to the negative 3, or 1/1000th of a liter. Again, you could use 1,000 milliliters is equal to 1 liter. It's the same ratio. And so now C2H3O2. Now I can cancel out the milliliters, and now I have liters of the silver acetate solution. And now I can use the molarity of the acetate solution. So here the molarity is 0.300 molar. So that means for every 1 liter of the silver acetate solution, I have 0.300 moles of silver acetate. And so let me write solution down just to be clear that here we're talking about the solution and not the solute. So liters of the acetate solution are going to cancel out. And now I have moles of the AgC2H3O2, the silver acetate. And they want to know the mass. So they say calculate the mass of the precipitate. So we're going to continue. But first we need to convert moles of the silver acetate to moles of silver chloride. So we're going to use our mole ratio. So we know that the mole ratio between silver acetate and silver chloride is 3:3. So we're going to use that. So 3 moles of the silver acetate on the bottom and 3 moles of silver chloride on top. So the moles of silver acetate cancel out. Now I have moles of silver chloride, but I want to get to mass in grams. So my last step is to use the molar mass of the silver chloride to convert moles to grams. And so you got to look that up and add that together. And when you do that, you get 143.32. 143.32. So I'm going to continue over here since we're out of room. So here I'm going to put the molar mass. So I have moles on top. So down here I'm going to have moles on the bottom. So 1 mole of AgCl on top, on the bottom. And then the mass, the molar mass, the grams, that's going to be 143.32. So 143.32 grams of AgCl. The moles of AgCl are going to cancel out. Now I have grams. So now all I need to do is multiply across the top, divide by the bottom, and I get my answer. And when I do that, I get 2.1498. 2.4198 grams of silver chloride formed from this amount of the silver acetate with 0.300 concentration. Okay, so now we have to do the same thing with the other reactant, the iron 3 chloride, and see how much silver chloride would come from that amount of that reactant. So we got to do the same thing. So we're going to start here. Again, we have 25 milliliters. So here we have 25.00 milliliters of the iron 3 chloride. And this is solution again over 1. And again, we're going to use the molarity to convert from the moles to liters, but we need liters first. So here we have milliliters. We're going to convert this to liters so that we can use the molarity. So again, 1 milliliter of the iron 3 chloride solution. is equal to 1/1000th, or 10 to the negative 3 liters of the iron 3 chloride solution. Milliliters of the solution cancel out. Now I have liters. Now I can use the molarity to convert to moles. So again, I have 0.300 molar solution. So that means that for 1 liter of the iron 3 chloride solution is going to give me 0.300 moles of iron 3 chloride. So the liters of solution cancel out. Now I have moles of the iron 3 chloride. Now I can use the mole ratio in my balanced equation to convert to moles of the silver chloride. So here it's a 1:3 ratio. So then I'm going to put 1 mole of the iron 3 chloride on the bottom and 3 moles of the silver chloride on top. So moles of the iron 3 chloride cancel out. Now I have moles of the silver chloride. And again, now I just need to use the molar mass to convert. So I'm going to use the molar mass here of silver chloride again to convert moles to grams. So again, I have 143.32. So 143.32 grams of AgCl on the top and 1 mole of AgCl on the bottom. So moles of AgCl cancel out. Now I have grams. So now all I need to do is, again, multiply by everything on the top, divide by everything on the bottom. And when I do that, I get an answer of 3.2247. So this is going to give us, what did I say? 3.2247. So 3.2247 grams of the, not iron, silver chloride. Okay, so now that I have the amounts that are produced, so again, this is the amount of silver chloride that would be produced from this amount of the silver acetate solution if this was to react to completion and it's all gone. So this here is the maximum amount of silver chloride that this amount of silver acetate can produce. This, same thing. This is the amount of silver chloride that can be produced from this amount of the iron 3 chloride. So if this was to react to completion, it would produce a maximum of 3.2247. Well, the amount of this silver acetate that we formed is not enough to create this amount. Because remember, this is the maximum amount we can get from this substance. So therefore, the silver acetate is the limiting reagent, and this is the amount of product that we get from this amount of silver acetate. So this is the mass of the silver acetate formed from this reaction. And the silver acetate, this is our limiting reactant. So LR for limiting reactant. Okay, so now that we've figured out what the mass of the product is, we can now use that to figure out what is the amount of each ion in solution. So let's go ahead and do that. Okay. So now what we need to do is figure out what is the amount of the moles. We need to figure out what the moles that were originally in the solution and after the solution was mixed together and after the reaction formed. So the reason we want moles is because we're asked for the concentration, and the normal concentration is to put it in molarity, and molarity is moles over liters. Okay, so we're going to start again with the amount of the silver acetate, and we're going to calculate the moles of each of the ions that were in solution before mixing. So let's start with aqueous solution of silver acetate. So we have 50 milliliters again, so 50.00 milliliters. Okay, and this is the silver acetate solution. Okay, so we're going to start with the silver acetate, and we're going to calculate the moles of each ion. Okay, so here we have 50 milliliters silver acetate. We're going to use the molarity again to convert to moles, which means that we're going to have to calculate, we're going to have to convert this to liters again. So we have 1 milliliter of the silver acetate, C2H3O2, and then 1/1000th of a liter, or 10 to the negative 3 liters of silver acetate on top. So milliliters cancels out. Now we can use the molarity again. So it's going to be 1 liter of the silver acetate solution, C2H3O2. And again, this is solution, just so that we're clear, not the solute. And then we're going to have 0.300 moles of the silver acetate solute. Okay, so liters are going to cancel out. And so now all we need to do is calculate the moles. Okay, and so when we do that, we calculate 0.015 moles of the solution. But we can also just calculate this to the silver ion or the acetate ion. So we notice here we can use a mole ratio from the formula. So I can convert moles of silver acetate to moles of silver or to moles of acetate ion. So let's go ahead, and we're going to have to do this with both anyway. So here, it's a 1-to-1 mole ratio. Why? Because for every one of these formula units, I have 1 silver ion and 1 acetate ion. So let's do silver first. So that means I'm going to put 1 mole of the silver acetate, on the bottom, and 1 mole of silver plus ions on top. So moles of the silver acetate cancel out. And so when I multiply across the top, divide by the bottom, I get my answer. And that is going to be, where'd it go? 0.015. So 0.015, let me double check, moles, but it's going to be 4 sig figs, no, 3 sig figs. I have 3 sig figs here. Remember, your answer should have the same number of sig figs as the least number of sig figs. Here I have 4. This is exact. Here's 3. So the least number is 3, so I should have a 0 there. So moles of silver ion. Now, you could do the calculation again and you could get the acetate ion, but the acetate ion is 1-to-1. So if you look at the mole ratio between silver and acetate ion, it's 1-to-1. So whatever the moles of silver you have, then that's going to be the moles of the acetate ion. So this is also going to be equal to 0.0150 moles of the acetate ion, C2H3O2 minus. So these are going to be equal in moles. Whether we have exactly that in solution, we won't be, because remember the silver is part of the precipitate, and so we lose some, if not all, of the silver, but we got to figure that out later. Okay, so this is the moles of silver we had in solution before the reaction. This is the moles of the acetate ion that we had in solution before the reaction. Okay, so let's go ahead and do the same for the iron 3 chloride. So I'm going to go ahead and do that down here. Again, we're going to start with the 25 milliliters of the iron 3 chloride. So 25.00 milliliters of FeCl3 over 1. We're going to convert this to liters. So on the bottom I have 1 milliliter of FeCl3. On the top I'm going to have 10 to the negative 3 liters of FeCl3. And again, this is solution. We're talking about the solution here. Solution. So milliliters of the solution cancel out. Now we have liters. So now I can use the molarity to convert to moles of the solute, FeCl3. So again, it's going to be 0.300 molar. So that means 1 liter of the FeCl3 solution on the bottom, and 0.300 moles. Shouldn't be a capital M, that's too confusing. Of the FeCl3. So liters of the solution cancel out. Now I have moles of the solute. So now I can convert moles of FeCl3 to moles of the iron or moles of the chloride ion. So I'm going to do iron. Iron, you could see, is a 1-to-1 ratio. So for every 1 formula unit, I get 1 atom. So it's a 1-to-1 mole ratio. For every 1 mole of the FeCl3, I get 1 mole of iron. So I can use that to convert 2 moles of iron ion. So 1 mole of the FeCl3 on the bottom, and 1 mole of Fe3 plus, or iron 3, on the top. So moles of the FeCl3 cancel out. Now I have moles of the iron 3 ion. So now I can just calculate that by multiplying across the top and dividing by the bottom. And when I do that, I get 0.0075. 0.00750 moles of Fe3 plus. So now I have the moles of the iron 3 plus the iron 3 ion in solution. Now all I need to do is calculate the number of moles of the chloride ion that were in solution. Now here you can see that the ratio of iron to chloride is 3-to-1. So I would have 3 times as much chloride ion in solution compared to the iron. So all I need to do is multiply this by 3 to get the moles of the chloride ion that are in solution. So when I do that, so let me write that out. So for the chloride ion, we could have 0.00750 moles of Fe3 plus over 1. And I can use the mole ratio in my equation of 1 iron ion for 3 chloride ions. So that means 1 mole of the iron 3 plus on the bottom, 3 moles of Cl minus on top. So the moles of the iron are going to cancel out, leaving me with moles of chloride. And I multiply that by 3. And when I do that, I get, let me see here. 0.225. So 0.225 moles of chloride ion. Okay, so I've got my chloride ion amount here. I've got my iron ion amount there, and I've got these amounts here. So now I have the amount of each ion before the reaction. Now I have to calculate the amount of each of the silver ions and chloride ions that ended up in the precipitate and subtract those from the original amount. So I have to subtract from here, and I got to subtract from here and see what's left over in the solution. Okay, so let's go ahead and do that. Okay, so now there's a couple ways you could do this. One way would be I could take the gram amount and I could convert the gram amount of my silver chloride into moles of silver and moles of the chloride ions, and then subtract that mole amount from the silver here and the chloride here, right? But I don't need to do that, right? Because remember, this is the limiting reagent. What does that mean? It means that the limiting reagent is the reactant that goes away, ends up being used up completely during the reaction, so I don't have any more left over. So that means that in this case, all of the silver ion is used up because it ends up in the precipitate. So if I had any more silver left over, it would keep reacting to make more of the product. But if this is the maximum amount of product that can be formed from this amount of the silver acetate, then that means that this is gone. So this is gone at completion, meaning that the silver here is going to be taken completely out of solution and it's going to end up here, right? So that means that at the end, all of this ends up in there. So the concentration of my silver is going to be 0 molar. So that's the concentration of silver. So I get that from the limiting reagent. Now, the other thing I know is that the chloride ion also ends up in the precipitate. So some of my chloride ion is gone. And so I can figure out how much chloride ion is left because I know that the silver and the chloride ion form a compound in a 1-to-1 ratio. So if I used 0.0150 moles in my silver chloride of the silver, right, then that means I needed an equal number of moles of the chloride ion to also bind with the silver to form the silver chloride. So that means if I use this amount, then that means I use that same amount of the chloride ion. So I need to subtract that from the 0.225 moles. So if I write that down here, it'd be 0.225 moles minus 0.0150 moles. And so when I do that, I get, let me see here, 0.075. Nope, that's not it. So that's going to be, let's see. Oh, I see. Okay, I think I made a mistake. Yep. So I forgot, I miswrote this. So that should be 0.0225. So I forgot my zero. Sorry about that. So that's going to be moles. That makes more sense. So here I'm going to have 0.02. Okay. So when I subtract that, okay, that's going to look much better. So when I subtract this, I get 0.0075, I believe. Let me double check my calculation. That is correct. So this is the number of moles of chloride ion left in solution. So now to get the concentration and molarity, I just take this number, 0.0075 moles of the chloride ion, and I'm going to divide that by the molarity, the number of liters I calculated. If you remember, when we add 50 milliliters to 25 milliliters, that was 75 milliliters, and that's the same as 0.075. So if I take the moles, divide that by 0.075 liters, if I divide that, I get 0.100. Let me just double check. Yep. So I get 0.100 molar, and that's equal to the concentration of Cl- ions in solution. So my silver 0, my chloride ions is 0.100. Now, for the other two ions, it's iron 3 ion and the acetate ion. Since they did not come together, they're not forming a solid, they're still floating around in solution. That's what the aqueous means. So that means I can just take the mole amounts, divide those by the liters. So same thing here. So for the acetate, I have 0.0150 moles. So for the concentration, the molarity of acetate ion is going to be equal to 0.0150 moles divided by 0.075 liters. And when I calculate that, I get 0.200 molar for my acetate ion concentration. And then for iron, same thing. I have 0.00750 moles of iron. So for my iron 3 plus concentration, again, it's going to be 0.00750 moles of iron 3 ion divided by 0.0750 liters. And again, that's going to be equal to 0.100 molar. And so that, ladies and gentlemen, is how you find the mass of the precipitate in your reaction, as well as the concentrations of the ions that are left over in the solution after the reaction. I hope this video was helpful. I know it was a long video, but there was a lot to go over in detail. I hope this was helpful. If this helped you, if you liked this video, if you enjoyed this video and you learned a lot from it, then please, by all means, like the video, share the video, hit the like button over there somewhere. Also, help me out. Hit that notification bell, subscribe to my channel. When you hit that notification bell, make sure you click all so you'll be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you need help with, or if you have a topic you want me to cover, please put that down below. I would love to do that for you. Thanks for joining me, and have a great day.